Necessity, they say, is the mother of invention. No wonder Nigeria's partnership with Israel has brought about the IFE Innovation Center to encourage young people to engage meaningfully and contribute their quota to nation building. Join me and see for yourself what innovation is about to offer Nigeria.
SkillG Innovation Center is actually a center where ideas are brought to life. It is a center that takes up whatever idea you have, whatever you may think, whatever thing you dream about. Once it is brought here, we make it come alive. That means this is an innovation center that brings solutions in every problems that innovators, researchers, and inventors have, especially in Nigeria. This is electronics lab. What we do here is we design schematics, we debug, we simulate. Whichever idea you have, we sit down here to think of how we can bring the electronic aspect of this idea into reality. So basically we are into designing the schematic, we debug the schematic, we create a PCB, that's a printed circuit board schematic, and we print it out and then mount those components on the PCB and produce whatever product you have.
Okay. How long will it take for any young Nigerian willing to learn this to really?
It takes your passion, interest, and commitment. Now, if any individual is committed and he has the passion, he is willing to work hard, it won't take a long time for him to understand what we are doing here. Now, the best thing about this place is that we give people free hand to roam around, to hover over every of this equipment through our guidance, and I think it's one of the best things you can do to an individual. So we have freedom of expression here. We are not restricted or bounded by laws and rules that you must touch this, you don't do this. We allow people to express themselves freely. So it takes just commitment, time, and focus to be able to achieve in this
Can you
place.
just take us around to explain this a bit?
Okay, like if you look at this is a microcontroller training system. We teach people what a microcontroller is. You know, there is this kind of ideology people have that it is very difficult for you to write a program. It is difficult for you to be able to control things using microsystems. But in this case, we teach students or trainees how to write programs, the basic aspects, the configurations, the architecture of microcontrollers. And this is a very good programming system because it has everything. In fact, this is just like a small computer. So this teaches about microcontrollers and microprocessors. Then we have electricity and semiconductors. Now, for you to send a signal to any part of the world, you use semiconductors, transistors, diodes, resistors. This is how, with this, we train people on how to use semiconductors. Now, this is a multimeter just to test the current, the voltages, because every electronic component is supposed to have signals and charges. And those charges could be in current or voltage. With this multimeter, we test the voltages, the current, and also the resistivity. Now, this is a power supply generator. For instance, if I want to power an Arduino that has 5 volts, all I need to do is to control the voltage here and also control the current and be able to control the Arduino system. This is also the same multimeter as I've shown you there. This is an oscilloscope. Every signal, every system has a signal. And if the signal does not work according to the design, that means the system will misbehave. Now, this is what introduces us to understand the basic aspects of the signals. Now, once the signal is connected here, we'll be able to have a visual representation of the signal. So this is just like a signal visualizer. It shows you the signal. If I'm expecting a direct current, I'm supposed to see a direct current like this. If I'm expecting a sinusoidal, I'm supposed to see a sinusoidal. But in the case where I do not see that, then I have to go back to my schematic or my circuit and see what is wrong. So this shows us the different aspects of signals that we're supposed to receive. Now, this is the same thing, an oscilloscope. And this side also, whatever you see here is the same thing that is on display. At the workstations, we build all our schematics here. After doing the design, we simulate them and we find out they are working. We breadboard them. We apply them, the components on breadboard. You know, you're not supposed to start soldering without testing to know if it's truly going to work. So after breadboarding them here, we now remove them and we use the soldering iron, we have the soldering lead, and we have the workstation to build the components on the system. So everything, when you open any kind of electronic system, you see the schematic, the PCB there. These are how the PCB are done.
In line with Nigeria's quest to get things right and make sure the youths are gainfully engaged, Israel and Nigeria, through the Office of the Vice President, have established the IFAIR Center to engage the youth meaningfully in innovation affairs. And where we are today is just one arm of the center, talking about how robotics are being created, how the ideas are being turned, and how youth can become more creative, not just to learn, but also to become creators of robotics. Here at the center, we have an engineer who will be taking us around to explain further how things work at the center. Join me.
So here is we have a lot of equipment that helps us to drive innovation. If you look at from this side, we have a greenhouse. You know, from this greenhouse, you can develop your gigantic kind of a greenhouse, and we have a kind of a tools that is a solar energy training system. We have again wind. We have a PLC. This PLC helps you to develop a system in a lift. Okay, from this PLC now you can develop lift. We have a lot of them, and we have robotics here. From here, students can learn how to do robots coding. From here again, we have a process control system. This this in robot system. This is a miniaturized 3D printer. We have for primary schools, all of them. Then we have for primary education system, we have a telescope. We have a demo board that teaches you question and answers here. This is exactly what our secondary and primary level needs to drive science home, you know. We have a lot of them. We have magnetism. We have purification of water, electricity. We have hydrolysis of water. We have prosthetics, all the model for biology. We have solar collectors, a lot of them. We have crushed can metal. We have electricity. We have a hydro generator. You have hydro dam. We have a lot of science tools. Now you can look at this side. This is for tertiary level. Then here we have a HVAC, heating, ventilation, and air condition. This is a simulator that helps you to explain everything about compressor, condenser, thermostatic expansion valve, and the compressors. Now, if you look at this side, we have the automotive. This is a demonstrator for lighting and signaling. That's what you see in your car, how you drive your car. The left trafficator, the horn, everything that is in your dashboard, that is a demonstrator for it. You can see here, this is car air condition and climate control simulator. This is about air conditioning in your car. Everything, how it works, the valve that is opening, everything that you see in your car about car air conditioning is here. And if you look at this simulator, this is about an engine control simulator. Everything that is in your engine, how your engine works, the carbon canister, the shut-off valve, the accelerator pedal, high pressure valve, the study of your engine, how it works, the science behind the engine and how it works is here. Again, you can look at this one is a multi-point injection system. It's about the injection demonstrators in your car. It is demonstrating what injection means in your car, how you can understand if something goes wrong. This shows you. Again, if you look at this place, you have the electronic ignition system. If you are looking at this, anything about ignition related problem that happens in your car, if you look at this module, you will understand how it gets wrong. You know, it shows you about the engine electronic control unit, what they call brain box. The communication between your brain box, that is the control unit, with every other component, consisting of the cylinders, the injections and the injectors and the ignition system, how control unit is controlling them. Then if you look at this place, it's about a hydraulic training system. Everything about hydraulics, every component, how it works, the principle behind the hydraulic, how it works, the electro-hydraulic system is here too. Now, if you look at, we have talked about this before, car air condition and climatic system. Now, this is pneumatic. You know, pneumatic and hydraulic, how they work, you know. So, pneumatic is about air, hydraulic is about oil, you know. So this is what shows you the principle behind the pneumatic system, how it works. Every valve here is controlled by what? Air. Okay, this is a tabletop computer numerical control lathe. I call it tabletop because you can see it's small. Not like this gigantic computer numerical control that is always big. So with this tabletop, you can design anything, everything you want within this level. Okay, this is CNC, computer numerical control. Now this is refrigeration and air conditioning. Is a demonstrator that shows you every component. The refrigeration cycle, you can see the compressor, you can see the evaporator, you can see the condenser, you can see all sort of thermostatic expansion valve, how it works as a closed system from beginning to the what? End. You can look at this one is CNC milling. We have talked about CNC lathe before. This is CNC milling. It mills every workpiece that you put there. Now you can look at this place, safety simulator. Safety simulator in the car. Anything about safety. The airbag, the door switch, the right turn, the brake, ignition switch, the hazard, the parking, everything about the safety simulator. That is what we have here. Now, this place is about, again, automotive. We call it ABS, 4-channel. ABS is those sensors that is in the wheel of your car. If anyone goes wrong, they are controlling the acceleration and deceleration of the wheels and transmitting information to the ECU.
How long does it take for one to really learn this? What duration will it take for one to really acquire the knowledge?
It depends, like 2 weeks, 3 weeks, 1 month. It depends on your level of understanding.
And what would be the ground stand or the foundation for anybody to start learning?
Well, science inclined subject is enough. You know, you can be a science student and so that you can understand all the science terms here. You know, and again for automotive, I don't think you need to be once you can understand driving components, like some components in your car, I think you can be able to. Everybody knows about braking system. You know, once you enter car, comes out, you have heard about brake. You know, everybody in the house has a kind of knowledge about refrigeration and air conditioning. Most people have fridges. You know, air conditioning. So the principle behind that air conditioning is what these demonstrators are really showing you. So it's not actually for maybe engineers, or once you can understand anything, you can understand. Then if you look at greenhouse there, you know, for innovators, you can understand with me that some of the fruits that we consume today, most of them don't grow in Nigeria. For instance, like apple. You know, but you can really control it. It's about controlling the humidity, temperature, and the air velocity, what we call the psychrometric ratios. You know, once you can control them, you can give that plant the required nutrients it will need to grow.